Okay, so make sure you have your foldable. It's called Applied Distance Problems at the top of it. So remember that we can use the Pythagorean theorem to find the distance between 2 points that form a diagonal on a coordinate plane. So remember when we had to find, like for example, if we had this picture right here. Pen's not working. If we had this picture right here, remember if we wanted to find the length of this red side down here, we could just count bubbles and say 1, 2, 3, 4. If we wanted to find the length of this blue side, we could still count bubbles and just do 1, 2, 3 bubbles high. But when we go diagonal, remember we're not allowed to count diagonal bubbles. So remember what we had to do. We had to do the Pythagorean theorem to figure out the length of this green side right here. So remember that we can use a squared plus b squared equals c squared. Remember that the c has to be the hypotenuse, which is the side opposite the right angle. So if the right angle was right here, you go across. And this one has to be the c, and the a and the b don't matter. So let's go ahead and apply that to a couple different types of problems that we might see. So the first example 1 says find the length of a segment of the line y equals 3x minus 6 from x equals 0 to x equals 4. Now we can go ahead and graph this old school like we did in 7th grade. So think about y equals mx plus b. Remember that m is our slope and b is our y-intercept. So if we look at this equation, it looks like he is in slope-intercept form. Y equals 3x minus 6. So it looks like right here, this is my slope, which is 3 over 1, because we want to rise and run. Remember, rise over run. And this right here is our y-intercept. And don't forget, that is actually a negative 6. It's where it crosses the y-axis. So we can just graph this easily. This is my y-axis. So remember, you always start off at your y-intercept. So this is my y. I got to go down to negative 6, which is way down here. And then from here, I have to rise 3 and run 1. So if I think about rising 3, 1, 2, 3, and running 1, that's going to put me right over there. And so my second point is right there. And I can continue up the graph. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. Rise 1, 2, 3, run 1. And I could do the whole entire graph like that if I want. And then I would just connect these. This is a line that goes forever. And it looks like that. Now I didn't have to graph that by hand. I could have simply typed this into Desmos and done y equals 3x minus 6. And I could have also drawn the picture by looking at this graph. It crosses at 2. And it crosses down at negative 6, which is what happened on my graph. Crosses at 2 and down at negative 6. So you don't have to graph by hand. You can use Desmos if you'd like. Okay, so we want to find the length of the segment. The length of the segment. Now this right now is not a segment. It's a line because he goes on forever in both directions. But we want the length of the segment only between where x equals 0 and x equals 4. So we need to go on our x-axis to 0, which is right here, and axis 4 is right here. So we basically want to know the length of the line in between those two, basically a wall. So think about a wall right here and a wall right here. So we don't want this stuff out here or this stuff out here. So we really only want the length of the line in between this area here on the interior of these two walls, which means I'm going to be going from, let me get a different color, I'm going to be going from right here and right here. So I want to know the length of this black segment right here. just inside the wall. I'm not going to go beyond this out here or down here, way over this way, because this graph does go on forever. It's just, it won't always end at the grid of the graph. This one just coincidentally did. Okay, so we need to find the length of this. Now it's diagonal, so we know we cannot count bubbles. So instead we need to make our fake triangle. Remember how we make a fake right triangle? I could either make it right up here or right down here. I'm just going to drop it right down here. Okay, I'm going to make this my fake right triangle. You see the yellow guy? Because he right here is the hypotenuse of this. So this is my right angle. So this guy over here has to be my C. And my A and B have to be my other two sides. And it doesn't really matter. So I'm going to just call him A. And I'm going to call this bottom side B. Now since these are horizontal and vertical, I can count bubbles. So counting bubbles from the bottom, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this length of this side is 12 long. Counting bubbles on the bottom, that's 1, 2, 3, 4. And I recommend you actually write the bubbles, because then you're not going to miscount. So now I have a right triangle where A is 12, B is 4, and C is missing. So I'm going to go ahead and do Pythagorean theorem, which we know is A squared plus B squared equals C squared. My A is 12, so that's 12 squared, plus my B is 4, that's 4 squared, equals C squared, which is missing. 12 to the second power, 12 times 12 is 144, plus 4 times 4 is 16, is equal to C squared. These are like terms, combine those babies, and I get 160 equals C squared. And then remember, to get it by itself, we clearly know this is not 160 blocks long. That's obnoxious. You're going to have to take the square root of both sides. So remember, take the square root of 160 in your calculator, and I get approximately, I'm going to go out about 4 decimal places because they don't really tell me. So this is 12 point, I'll go out 3 decimal places, 12.649 approximately. And that makes more sense that this length is about 12. Remember, C has to be the longest side. So this side was 12, and that was 4. So C has to be longer than 12. So this side being 12.649 seems to be a good number. Remember, always put it back in your picture and see if it makes sense. Okay, let's go to the inside. Now this is one big bad problem. Lots of steps. So take your time when you graph the points. So make sure that everything's right. So we're going to draw the figure with vertices at C is 2, 5. So that's over 2 and up 5. That's this guy. Call him C. D is at negative 6, 1. Back 6, up 1. This is my D. E is at negative 4, negative 3. So that's back 4 and down 3. That's right here. That is my E. And F is 2, 0. So that means over 2 and up 0. That is my F. Okay. It says draw the figure with the vertices there. So that means I need to connect this figure. So I've got this, 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 this. Okay, so it says make an educated guess about the type of figure you have drawn. So go ahead and just fill in that space. What shape you think that this is. I'm going to leave that blank right now, but you're filling in a shape because you're supposed to be guessing. I'm not going to tell you how to guess. Okay, so the next thing I'm going to do, in order to figure out what shape it is, like if you thought it was a rectangle, then you know that it has to have opposite sides parallel and right angles, right? If you said, hey, I think that this is a square, then you would know that all the sides have to be the same length. If I said, hey, I think this is a rhombus, then you needed opposite sides parallel and all the sides the same length. But you don't need right angles. So finding the slopes and lengths of sides is going to help you narrow down exactly what shape this is. Okay, so we're going to go ahead and determine the slope of each side of this figure. So we're first going to do side C to F. So I'm going to start this guy pink, C to F. What is the slope of that? So that is rise 1, 2, 3, 4, 5, and run 0. So that's a 5 over a 0. Now, if you put that in your calculator, you're going to get an error. Because remember, you can't have 0 on the bottom. So whenever that happens, you're just going to write undefined. Undefined. That's the slope of that line. It is undefined, basically illegal. Okay, so let's go find the slope of, I'm going to go across, CD next. So C to D. This is going to be orange. Color code your stuff so it's easy. Okay, now I need slope, and remember that's going to be rise over run. So I'm going to go ahead and start down at this D, count bubbles, rise 1, 2, 3, 4, and run 1, 2, 3, 4, 5, 6, 7, 8. And this is going uphill, so it should have a positive slope, right? So I'm going to get rise what? 4 and run 8. 4 over 8 simplifies to 1/2 because if you ate 4 pieces of pizza out of an 8-cut pizza, that is a half a pizza, right? So I'm going to go ahead and write that really small on this line. M equals 1/2. Oh my gosh, that's a half. And over here, I'm just going to put UND for undefined. Okay? That is a 2. That's the ugliest 2 in the world. Okay, that looks a little better. Okay, let's do DE. D to E is right here. Okay, so this is downhill, so I'm going to anticipate this to be negative. I'm going to put that negative there because I like to check it. So I'm going to start down here and rise 1, 2, 3, 4, and then run -2. So that's a rise 4 and a run -2. So that would be like this negative's down there. So the whole thing is negative. So it's a -4 over 2. -4 over 2. -4 divided by 2 is just -2. So that is my slope, -2. My last side, I'm going to do blue, is from E to F. This is going uphill, so I anticipate this to be a positive, uphill, increasing. So I'm going to start at E and do 1, 2, 3, and then run 1, 2, 3, 4, 5, 6. So that is a slope of 3 over 6. And that does also simplify to 1/2. If I ate 3 pizzas out of 6 of them, that would be half of my pizza. Okay, I'm going to put 1/2. My M equals 1/2 on this. And on this guy, my M equals -2. Okay, so I have my slopes labeled really small in here. Okay, so what can we say? When we have the same slopes, 1/2 and 1/2, that's telling us that these are slanted the exact same way. So rising 1 and running 2, rising 1, running 2. And that means that these two are parallel. So I'm going to go ahead and put little parallel arrows on here. Those guys are parallel. Now, what can we say about this corner and or this corner? So remember, if this is 1/2, and this is -2, what do we know about 1/2 and -2? Those are opposite reciprocals. Those are opposite reciprocals. And what do we know about opposite reciprocals? We know that that means those lines are perpendicular then, which means I could put the little box here and here because these are opposite reciprocals. So it looks like this shape is a trapezoid because the trapezoid has the top and the bottom parallel, but the other two sides are not parallel. So we can see that this is at 90 degrees, but this one is not. So this actually is a trapezoid. Did you guess that right? Trapezoid. All right. Okay, we're going to go and find the perimeter now. So remember, perimeter is the length of all of these sides, not area, perimeter. So we need to figure out how long all of these sides are. And this is where we're about to make a mess of this picture, because there's only one of these 4 sides that's going to be easy. this side right here from C to F, do you see how from C to F, I can simply count bubbles? 1, 2, 3, 4, 5. The length of this side is 5 units long. And I can count bubbles because he is either horizontal or vertical, straight up and down, so I can count bubbles. So that means the length of side C to F is equal to 5. That's the easy side. All of these other 3 sides are diagonals, which means I cannot count bubbles. Instead, I'm going to have to make a bunch of fake right triangles. Okay, so you're going to need some, I would get colored pencils or something that's really light. Okay, so let's start with this blue side down here. I'm going to use highlighter because that shows up best on here. I'm going to use this blue highlighter. Okay, so you see this side right here? I can make a fake right triangle right here. Do you see how I'm doing this fake right triangle? You see him right here? Okay, I can make this fake right triangle because I can easily find this side, and then I can do Pythagorean theorem to find that side. Okay, so I can count some bubbles and do some sides. So this side here is how tall. Oopsie, I want to undo that. I don't want that to show up. This side is 3 tall, correct? And then if I count bubbles across the bottom, 1, 2, 3, 4, 5, 6. That was 6. Okay, so here's my little right triangle with A side is 3, B side is 6, and C side is missing. So I'm going to scroll a little bit. Okay. I'm going to move this down. Oh, no, I should move it up. Because that's what I'm actually finding right now. I'm finding the perimeter. I'll put it right there. How about that? Is that cool? It's kind of in the way. Nah, it's fine. Okay, I'm going to do my little triangle. I'm going to draw a picture of that little triangle so I remember. You see him? This is my little blue guy. This is my right triangle. This is a 3, and this is a 6. And I'm trying to find this side right here. So this is the side I don't know. The C side. Okay, so I'm going to do a squared plus b squared equals c squared. So that is a 3 squared plus a 6 squared equals c squared. I don't know. So 3 squared is 9 plus 6 squared is 36 equals c squared. What is 36 plus 9 is 45 equals c squared. And then I'm going to have to put that in my calculator and find the square root. So I'm going to get C is approximately. Now here's the deal. It says to round it to the nearest tenth, right? But when you're working with a big problem like this, you never round to the tenth until you are all done. So as you're doing your work, it's standard just to go out 4 decimal places. And then when we're all done with all of our math, we'll round it at the very end. Okay, so from C to F, that is our 3 and our 6. If I take the square root of 45 on my calculator, is approximately 6.7082. Okay, so this side right here is 6.7082. Okay, you see how I got to now do that to the green side and the orange side. Okie dokie. I would pause the video if I were you and see if you could do it yourself, and then start the video back up and see if you get the same answers instead of just copying it off of me. Okay, let's go ahead. I'm going to do it. You pause the video. Start it up when you're done. Okay, I assume you pause the video and you start it up. So here's my right triangle. Remember, you could have done the right triangle up here too. It wouldn't matter. You're still going to get what numbers on the side? You're still going to get 2 down here and a 1, 2, 3, 4 going up the side. So my little right triangle, my little green one, looks like this, right? Right triangle has a 2 here, a 4 here, and a C there because I don't know that one. So that's going to be a 4 squared plus a 2 squared equals a c squared. So that's a 16 plus a 4 equals c squared. You already did this, right? So you pause the video and you did this yourself. take the square root, take the square root. Remember, once again, go out about 4 decimal places until we're all done. So the square root of 20 is approximately 4.4721. Okay, now we got to do the third side, which is this orange side up top here. So this orange side, I don't have orange. I'll pretend like I'm doing yellow. Okay, up here is fine. You also could have done it down here. It wouldn't matter. Your side lengths are going to be, what's this across here? 8. And going up here is 4. So when I do my Pythagorean theorem, that's going to be an 8 squared plus a 4 squared equals c squared. So I'm going to scroll down here. So that triangle up at the top, that looks like, I can't draw it without looking at it. It looks like this. So I've got an 8 and a 4. So 8 squared plus 4 squared equals c squared. So that was a 64 plus a 16 equals a c squared. 64 and 16 make 80 equals c squared. I need square root. And so the approximate square root, going out about 4 decimal places, of 80 is 8.942. Okay, now do I have all 4 links? I'm going to put them in my picture. This side was about 8.9442. I've got my blue one down here. I've got my red one, or my pink one, which was 5. I need my green one. What was my green side? My green side was the 2x4 one, which was about 4.4721. Okay, so I have all of my side lengths now, all 4 of them. 1, 2, 3, 4. Now remember, to find perimeter, I need to add all 4 of these up. So you're going to add up this number, plus that number, plus that number, plus that number. Okay, so what do we get for our perimeter? Perimeter, if I add up those 4 numbers, I get approximately 25.1245. And then the directions say to round it to the 10th place. Oopsie. 10th place is this 1 right here. But remember, you got to look at the 2 to see if you need to shove him or not. So the correct answer would be the perimeter is 25.1. Because you cut it off at the 1's place, because I'm not shoving it. Because of this 2 is not 5 or above, so no shoving. And we don't know what the unit of measure is, so I'm just going to say units. 25.1 units, approximately. Okay, now we're going to use all of this same information to answer the question about finding the area. Okay, and just for the sake of not being able to scroll up and down the screen, I'm going to take a clip of this, just so I have all of this information down below. Let me paste this down here by this other. Now you have a foldable, so you can see it. Okay, now this is different. They're asking for the area. Oh, hello, big picture. They're asking for the area. So remember area, we're going to have to use some of our area formulas. Okay, so the only ones we know, we do know the area of a parallelogram, right? We know that that equals base times height. Oopsie, that's an H. Base times height. We also know the area of a triangle is on our formula sheet, and we know that that is 1/2 times base times height. We actually also learned a trapezoid, which is actually what this is. So we could use the formula for a trapezoid. But remember, that was like 1/2. And remember, you had to add the bases. Base 1 plus base 2. That's a 2. And then you had to times that by the height. Or we can just take this picture and cut it. So I'm actually not going to use the formula, only because this formula is not on the formula sheet, so chances are you might not remember it. So let's just use these two because these are easy, and we know that we can cut this picture, right? Because if I just do one little cut right here, what color should I cut this? I'm going to cut it in purple. If I just cut this right here, boink, do you see how I'm going to have a parallelogram right here, this box, and I'm also going to have a triangle. And then I could just do each one separate and add them together. And then I don't have to worry if I forgot this formula. Okay, so let's do this box first. So the area of the box, we know, is base times the height. So we need to basically tip this box over. And what is the base? The base right here is 6.7082, right? And then the height of it would be standing straight up tall, which would be the 4.4721. So all we have to do is multiply these two numbers together, and we'll get the area of the box. Okay, so the area of the box I got to be about 29.9997 or something like that. So it's pretty darn close to 30, right? And if you look in here, see if it makes sense to counting these. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So this does look, it's about like 30 boxes in there. So this is a perfectly fine answer that makes sense. Now let's go ahead and do the triangle on the side. So we need this triangle over here. I don't even have any more colors to use. What color have we not used? Let's use this pretty aqua color. Okay, so I'm going to do this triangle over here, right? Now this is a right triangle, right? Because it's going straight up. So we need 1/2. Here's the area of the triangle. We need 1/2 times the base times the height. Now he's clearly crooked, right? So his base might be this top piece right here. So we need to figure out how long that is. And there's no number from there to there, right? But we do have that this is 6.7082, and this whole thing is 8.9 something, right? So we can just subtract these two numbers to get this little piece right here. Because we know, once again, this part is 6.7082. So if we subtract so 8.9442 minus that 6.7082. If we subtract those from each other, we're going to get this top piece to be about 2.236 if you subtract those two. So that means that our base is going to be 2, we have 1/2 times our base, which is 2.236, times, we need our height. So how tall is this? Now there is no number here, but isn't it just the opposite side of this? Which means if this is 4.4721, then that means this side of the box has to be that too. So we're timesing it by 4.4721. So we have to do 1/2 times 2.236 times 4.4721, and we get approximately 4.999. So all we have to do is add these two together, right? So if we add these two together, we get approximately, we literally get like 34.998. And this one doesn't say what to round it to, so I would legit just be like, it is approximately 35 square units, or units squared. Okay. And if you're in Castor's room, you're gluing this baby on page 26.